In this example, we're going to graph the quadratic f of x equals negative x squared plus 5x minus 4. And while it's in the polynomial form of a quadratic equation, we can easily determine the y-intercept by letting x equal 0. So in this case, we have y, or f of x, is going to be negative 0 squared plus 5 times 0 minus 4. And that will be 0 plus 0 equals negative 4. So the coordinate is going to be 0, negative 4. The next thing we need to do is find the x-intercepts by letting y equal 0, or f of x equal 0. So in this case, we're going to have 0 is equal to negative x squared plus 5x minus 4. So multiplying every single term on both sides of the equation by negative 1, we can find that positive x squared minus 5x plus 4 is equal to 0. And we can easily inspect that quadratic to find the factorized form. So the two numbers that multiply together to give positive 4 and add together to give negative 5 are going to be negative 1 and negative 4. So you can check the expansion of that and check that you get back to x squared minus 5x plus 4. So next we use the Null Factor Law to say, therefore, x minus 1 equals 0, or x minus 4 equals 0. So solving, if we add 1 to both sides, we get that x is equal to 1. And for the second, if we add 4 to both sides, we get that x is equal to positive 4. So the final thing we need to do is find the turning point for the quadratic, and we can do this by either completing the square or using the axis of symmetry. So in this video we're going to use the axis of symmetry, which says that x is equal to minus b divided by 2a, where we can get the values of a, b, and c from the equation above. So a equals negative 1, b equals 5, and c equals negative 4. So subbing those into the axis of symmetry, we get negative 5 over 2 times negative 1, and that's going to give positive 5 on 2. And now the next thing we need to do is find the function value when x is 5 on 2. So we go and we substitute 5 on 2 into f of x. So subbing 5 on 2 into f of x gives negative 5 on 2 all squared plus 5 times 5 on 2 minus 4. So this is equal to minus 25 on 4 plus 25 on 2 minus 4. And if we get a common denominator, we can add these together, which will give minus 25 on 4. And then this will be plus 50 on 4. And then minus 16 on 4. And all up, that is equal to 9 on 4. So therefore, we can say that the turning point occurs at the coordinate xy is equal to 5 on 2, 9 on 4. So what we now need to do now is plot all of the points that we've found. So the y-intercept is at negative 4. So that is 0, negative 4. The x-intercepts were at 1 and 4. So we have the x-intercept at 1, 0, and the x-intercept at 4, 0. And then we have the turning point halfway between these two values at 5 on 2, and 9 on 4 is about 2.25. So it's somewhere around there at 5 on 2, 9 on 4. So finally, we just put a concave down parabola through all of these points. And we know that it's concave down because the a value up here is negative. So because that's negative, we know that it's concave down. And by plotting all the points, we see that that's the only way we can fit a parabola through all of those points. So on this slide, we've just got a computer to generate that curve, and we can see that all the same points are listed here, the x-intercepts of 1 and 4, the y-intercept of -4, and the turning point at 2.5, 2.25, which is the same as the 5 on 2, 9 on 4 that we had previously.